Our next speaker in line is Ashok Kumar. Ashok Kumar is an engineering leader for TransUnion. He is accountable for advocating quality through leadership and maximizing customer trust in their products. He works with TransUnion as a global technology leader representing quality engineering within their African business. Ashok is an international speaker, blogger, and mentor in external forums. He is passionate about accelerating financial inclusion through building world-class credit bureau solutions for emerging markets. Ashok specializes in test strategy, building robust automation solutions in testing and test leadership. So here's Ashok Kumar presenting Smoke to Avoid Fire. Welcome to Ubuntu Testing, Ashok.
Thanks for the introduction. Let me put my presentation mode. So hello, everyone. Welcome you all to my talk, Smoke to Avoid Fire. My name is Ashok. I'm an engineering leader with TransUnion as I was introduced. And I'm actually responsible for quality assurance and engineering within TransUnion as a company. And a brief about the organization that I work for. We basically operate credit bureaus, and we do this worldwide across 30 different countries. And my team is responsible for ensuring that all of these credit bureau solutions that we build worldwide are as per quality and meet the quality standards. Now, I'm also passionate about test strategy, leadership, test automation, and customer advocacy. Those are my areas of expertise. And outside of work specifically, I publish blogs in multiple external platforms. I'm an international conference speaker. I've been speaking in testing events worldwide and within Asia as well. And I'm also passionate about mentoring young test engineers who are new to their testing and quality assurance careers. So that's a brief about me. And in the next couple of few minutes, I will be talking to you all about our journey of building an effective smoke testing pipeline and some of the challenges that we as teams go through when we initially implement smoke testing as a process. I'll also touch upon some practical tips and solutions that has worked well for us, and I hope that those tips will also be relevant to you all when you embark on this journey of smoke testing and smoke testing techniques. And I'll also talk about reference architecture, which is a technical architecture that we have put together based on our experience of building smoke testing. And most of these architectures are designed in such a way that they are Lego block architectures, which means that while the tools and the technical stack of the architecture might differ from team to team or from across different companies, the concept remains the same. So you could basically lift and shift that architecture and into your own teams and replace the tools with what you have as tools in your organization as well. So as a precursor to this event, what I did was I ran an online poll amongst my LinkedIn followers. And basically what I asked them was, I asked them to briefly describe in a few words what according to them smoke testing means to them. Now, based on the survey results that I received through that poll, I categorized that survey results into 5 distinct categories of 5 distinct buckets. And I wanted to present my findings through my survey through in this talk as well. So the first category of responses that I got through my poll for what according to them smoke testing is all about states that smoke testing is the same as sanity testing. Now, this is a classical confusion that exists across the software testing domain as well. And in my presentation today, I would want to basically debunk this myth and also try and, as much as possible, clearly define what smoke testing is all about. And that will basically help us to understand how it is differentiated from what sanity testing is. So the second category of response that I received through the online poll is that states that smoke testing checks the stability of the application. Now, this is more or less true because the essence of my talk as well today revolves around how smoke testing is an essential parameter or lever that helps us to monitor the stability of applications. And as we navigate the slides today, you will also see what benefits that we as teams have got through maintaining an effective smoke testing pipeline that checks the environment stability and keeps alerting us of problems within the test environments when applications go down. The third category of response that I received through the audience poll stated that smoke checks validates the functionality of an application. Now, this again is partly right and partly wrong. Why it's right? Because in the event of checking the stability of an application, you also can check the functionality of an application. And why it is wrong? Because checking the functionality of an application when it becomes the primary motive of your smoke testing process, then it basically deviates your smoke testing from the original purpose of what it was designed for. And that deviation can cause this confusion between what smoke testing is and how it is differentiated from the other forms of testing as well.
Ashok, excuse me. I think we're only seeing the first slide of your presentation. Is it possible? We're seeing like the front page only. Now we can see another one. Yeah. Okay.
Oh, okay. Okay. So I think the play mode is not working. So maybe I'll navigate the slides manually.
Okay. Okay.
Okay, cool. Okay, sorry about that. Now, the fourth category of responses that I received through the poll states that smoke testing basically slows down the release pipeline. Now, this is a classical example of developers always trying to say that any form of testing slows down their ability to push changes into production or into higher environments. Now, as we go through the slides, you will see how in our team's example, we were able to actually accelerate the changes into production rather than slowing down the changes that go into production. And the final category of response was from the testing community within my survey participants who felt that smoke testing should always be automated. Now, this again is a statement that is partly correct and partly wrong as well, because while it is good to have your smoke checks automated, it is not essential for your smoke checks to be always automated, because you need to kickstart your smoke testing as soon as possible and start gaining value out of it. And if that means that running manual checks on your applications to check the stability of the application, that also is fine. Let me move on to the next slide. Sorry, my slide navigation is not happening. Okay, I think my slides are not navigating.
Okay, Ashok, do you want us to share your presentation for you?
Yes, please.
Okay, give me a second.
Okay, sorry about that. Yeah. Can you go to slide number 4, please? Yeah, thank you. So as I was putting together the slides for my talk, and specifically for this talk, I came across this kind of a picture that resonates with the overall message that I wanted to convey through my presentation today. Now, the banner that you see on the picture is ideally your smoke testing process that currently needs to run on your test environments. And the bridge that you see there is the actual test execution life cycle that we as testers go through when we perform our test execution. Now, if you're able to pass through the banner without hitting the banner, you will also definitely be able to pass through the bridge as well. This is a happy path scenario. Now, on the contrary, when you pass through the banner, you hit the banner, you're still okay because you can still make corrections, do fixes, course correct, change things before you eventually reach the bridge, because you can now successfully pass through the bridge as well. This analogy of the banner and the bridge perfectly fits into the definition of what smoke testing is all about. Now, smoke testing is a testing technique that smokes an application to test the application's ability to stay stable or not. Now, when this scope of smoke testing is clearly understood, you will be able to design your smoke testing for the right purpose that it was actually meant for. And this will also be able to help you differentiate from what smoke testing is all about and what smoke testing is not all about, more importantly. And that basically will demystify the myth that we saw in the previous slide, where the audience responded that smoke testing is similar to sanity testing, or smoke testing is the same as regression testing, or smoke testing checks the functionality of the application. Can we move on to the next slide, please? So now the need for smoke testing, I wanted to talk about this need from two different perspectives. One is the industry's perspective. Next slide, please. Which is the perspective of analysts who research the software testing market and publish their analyst findings. Now, a recent study by Gartner indicates that nearly 25% of testers' capacity is wasted because when they start test execution, that's when they notice that certain applications within their test environments or within their end-to-end test chain is actually not up and running. And this results in testers' capacity being ineffectively managed. Now, another study by Forrester also reveals that of the overall test execution lifecycle time, nearly 50% of the time, the test environments are not available to the testers. And this results in testing capacity being ineffectively managed, as in the previous study highlighted by Gartner as well. Also, a study by Capgemini reveals that nearly 60% of the defects that are logged during test execution are actually environmental defects. These are defects that are that could have ideally been identified and fixed much earlier if we would have had an effective smoke testing process in place. The same study by Capgemini also further goes on to say that nearly 80% of the teams report success with their test automation when they have a stable test environment in place, which means that the stability of test environments or applications within test environments directly impact the automation success rate for that particular team. Can we move on to the next slides, please? Okay. Now that we have seen the industry's perspective, I also wanted to talk about an insider's perspective, which is the perspective of teams like us. When we initially wanted to implement smoke testing as a process, we identified certain key objectives that we wanted to achieve through our smoke testing. The first one being, we wanted our smoke testing to help us monitor our environment stability. And we also wanted to ensure that any problems with our application stability can be identified and reported much earlier. So now that we had this expectation from our smoke testing to monitor environment stability and also alert us of potential problems within the stability of the applications much earlier, we also had an inherent expectation from our smoke testing process to help us manage our testing capacity itself much more effectively, because that was the key problem that the analysts also find in the current test environments and the current test executions that teams are doing, because the testing capacity becomes idle and they're not being managed effectively. Now, as we transition from a waterfall into an agile mode of working, we noticed a trend amongst our development teams to check in code much more effectively into much more frequently into our environments. While this is good from an agile perspective, it also has a problem associated with it. which is the problem of frequently checking in untested code into a lower environment that can adversely impact the stability of the environment. We wanted our smoke testing to basically create that safety net for our development community so that they can check in code much more confidently into the environment and much more frequently into the environment as well. So through this objective, we are trying to debunk the myth of developers that smoke testing actually slows down their ability to release code into higher environments much more faster. We finally also had the objective that was set for our smoke testing process to enable a continuous feedback loop that can constantly monitor and alert our application stability within our environments. Next slide, please. Okay, so considering all of these objectives, we put together a reference architecture. This is a Lego block architecture that I usually speak about. I call this Lego blocks because each of these blocks can be interchanged with tools that are relevant to your own organization or your own tools or your own teams. But the underlying concept or underlying philosophy through which we are trying to implement this architecture remains the same. Now, the lower part of the architecture is the actual applications that need to be smoke checked. The lower left, where I've specified app 1, app 2. Those are the actual applications that need to be smoke checked. While we did not invest a lot of effort in building a customized test automation framework specific for smoke testing, we repurpose that effort to actually be invested in identifying the right checks that need to be automated. Now, each of these smoke check jobs were configured into a Jenkins master node, and the jobs were scheduled to run at specified intervals. Now, the Jenkins master node itself was configured to trigger multiple Jenkins agent nodes, and these Jenkins agents had the capability to spawn smoke check jobs parallelly. We also had an agent monitoring mechanism that was configured into our framework that monitors the health of these agents and had the capability to automatically restart these agents when any of these agents go down. Now, this is the self-healing capability that we implemented within our smoke testing frameworks. Within each of these agents, we also had executor threads configured. Now, each of these executor threads again had the capability to trigger smoke check jobs parallel. So the parallel execution of smoke check jobs was achieved at the agent level and also within each of these agents in the form of executor threads. This sort of parallel execution of smoke check jobs helped us to rapidly ensure feedback from our smoke testing executions because fast feedback is the utmost critical necessity of a smoke testing pipeline so that our developers and the support community will be able to immediately be alerted about potential application instability problems within the environment, and they will be able to go ahead and fix them. Can we move on to the next slide, please? Yeah. So as we started implementing smoke testing as a initiative or as a technique within our teams, we noticed some pitfalls that teams typically go into when they implement this smoke testing process. The first one being teams tend to create very bloated checks. Now, when a smoke check tends to be a lot more holistic and tries to test the functionality of an application or the regression capabilities of an application, that's when a smoke check becomes a bloated check. Now, the problem with these bloated checks is that they tend to slow down the overall feedback speed that we expect out of a smoke testing pipeline. And this also emerges from our confusion of what a smoke test is all about and what is the key objective that we need to achieve through a smoke testing pipeline. And when that objective or when that scope is clearly defined, I think the teams will gradually move away from creating bloated checks into creating much more nimble and atomic checks. Next slide, please. The second pitfall that teams typically tend to get into is that they try to design their checks more towards the UI layer and less towards the database or the service layer. Now, the problem with these UI checks is that they tend to be inherently flaky, and this results in a lot of false positives or false negatives getting injected into our overall smoke testing feedback. Now, the other problem associated with these UI checks is that they also tend to be a lot more heavyweight, and this adds to the problem of slower smoke testing feedback. Next slide, please. As we started implementing our smoke testing process, we had two options in front of us. Option one was to create or develop a smoke testing automation framework from scratch with all of the regular capabilities of a test automation framework, such as externalized data, reporting capabilities, logging capabilities, and all of that. The second option that was in front of us was to lift and shift from an existing regression automation frameworks and repurpose them into smoke testing frameworks. We went for option two because we didn't want to over-engineer our test automation frameworks, and we wanted to quickly kickstart our smoke testing initiative and start gaining value out of it. Now, this pitfall is more or less related to the survey result that we saw in the first slide as well, where teams were waiting for getting all of their smoke checks to be automated before they actually start running smoke tests. So we need to actually, as early as possible, start running smoke checks, even if they be manual or even if you have to repurpose automation frameworks. The key is to start executing these smoke checks and start gaining value out of it. Next slide, please. Yeah. So as we started executing our smoke testing pipeline, we noticed a lot of failures getting reported into our smoke testing reports. Now, when we deep dived on these failures, we noticed that these failures were not actually failures indicating problems with our stability of applications, but these were failures because the underlying infrastructure within on which a smoke testing pipeline was running, that infrastructure was going down or becoming flaky. Now, in our example, this infrastructure is our Jenkins agents. And that's when we implemented our agent monitoring scripts to monitor the health of our agents and automatically restart them when they go down. So basically, we're trying to remove the noise as much as possible from our smoke testing signals. And that's what we also did with our UI checks problem as well. We, as much as possible, try and remove the flakiness out of our smoke testing signals so that we do not have a lot of noise in those signals. Next slide, please. Finally, we needed to maintain the right balance between how much coverage we enable through our smoke checks and how fast is our smoke testing feedback. Because in a testing technique like smoke, speed is of utmost importance, and we need to maintain the right balance between coverage and speed. Next slide, please. So some of the key metrics that we measure to basically gauge the effectiveness of our smoke testing pipeline is the first metric is our smoke test execution time, which is the total time required to complete a smoke testing execution. And this time is very critical to us because it is a key metric that helps us to measure the rapidness of our smoke testing feedback. And we constantly optimize our smoke test pipelines for speed. The second metric we measure is the smoke test pass rate, which is the rate at which smoke checks are passing within our smoke testing pipeline. And the third key metric that we also measure is the flakiness rate, which is the rate at which tests become flaky in our smoke checks. And the flakiness rate is very critical to our effectiveness of our smoke testing pipeline because these flaky tests add to two problems for our smoke testing processes. The first problem is that they tend to slow down the overall feedback speed that we expect out of our smoke testing. And the second problem is that they tend to inject a lot of noise into our smoke testing pipelines by a lot of false positives or false negatives getting added. Next slide, please. So I wanted to also talk about our success story with smoke testing implementation. We were able to smoke check 21 applications with 40 atomic checks in an overall runtime of 9 minutes across 3 different environments, SIT, UAT, and prod. And we've logged overall 33 defects so far, which are all environmental problems. These are problems that could have literally stalled our test execution or put us in a state wherein our testing capacity would have been ineffectively managed. Next slide, please. So looking into the future, these are some of the key initiatives that we are currently working on with regards to smoke testing. The first one being we consistently optimize for speed, which means that we will constantly relook into our smoke checks and try to remove any bloated checks that still exist within our test environments. We are also tilting the balance more towards the database and the service level checks rather than the UI checks. The second initiative that we're working on is building a centralized reporting dashboard on top of Grafana. This sort of dashboard could help us build a lot of customized reporting for our stakeholders. One example of report is that we want to build a report that basically shows a trended view of how an application transitions from a state of stability into a state of instability. Finally, the third initiative that we are currently busy with is we're trying to build machine learning models that can learn on our past smoke check logs or smoke testing logs and potentially have the capability to predict which type of code check-in on which application can potentially impact the stability of the application even before the check-in is made into the environment. So we're trying to literally shift left our smoke testing further back. Now, these are some of the cool initiatives that we are currently working on, and I will be able to share more insights and more challenges that we face as we start and working on these initiatives. So that's about it from me. Thank you. Thanks for your time.
Thank you so much, Ashok, for your thorough presentation. That's a lot of knowledge. Really instructive. We have here some questions, okay? Please, the audience, if you have any further questions, don't hesitate to ask through the Q&A. So, Ashok, how do you recommend balancing speed and coverage while still keeping the metrics meaningful?
Okay, the metric itself is a measure of how we maintain this balance. The total elapsed time that I spoke about, that is a key metric that we monitor to maintain this balance. Now, when that execution time becomes higher, then that indicates that this balance is tilted more towards coverage and less towards speed. So right now we are at a execution time of 9 minutes runtime, as I spoke about in the slides. But we are constantly trying to optimize that for speed. We're trying to bring that down to 6 minutes. And that's how we ensure that the balance is managed between coverage and speed.
Among the common pitfalls you mentioned, bloated checks, UI checks, or over-engineered frameworks, which one do you see teams struggle with the most in practice, and how can they best avoid it?
So I think the key struggle that I've seen repeatedly happening in teams is the bloated checks. So they try to cover everything in smoke test because they want their smoke checks to do their functional end-to-end testing. They want to do the regression testing through their smoke testing pipeline, which is actually not the objective of an effective smoke check. So the bloated checks is the topmost culprit in the pitfall. And when you try and avoid that, you get maximum benefit out of your smoke testing.
Thank you, Ashok. We have here another question. How can teams best monitor environment stability without adding too much overhead to the smoke test suite?
Okay, I think the key aspect of that is to start executing a smoke test as soon as possible. So you shouldn't be waiting for all of your applications to be automated and up and running in the pipeline before you start executing a smoke testing pipeline. You should actually start it as early as possible so that you start gaining value out of it. The earlier you kickstart your smoke testing initiative, the more valuable it is.
Thank you so much, Ashok. I think we have no further questions here. For the audience, if any questions remain unanswered, you can contact the speaker throughout his LinkedIn. Okay, so it's Ashok S. Kumar. Our team will leave it in the chat.
Thank you.
Thank you so much for being here, Ashok, with us in Quality Testing 2025.
Thank you. Thanks, everyone.
Thank you. Bye.